Good morning everyone. Welcome to our third online session for Calculus 2. So for this session, we will focus on implicit differentiation and higher order derivatives. When is it an explicit function and when is it considered an implicit function? So when we say explicit function is a function in which one variable is defined only in terms of the other variable. Okay? For example, your quadratic function y equal to ax squared plus bx plus c, y is expressed in terms of the variable x only. Okay? Y equal to x squared plus 7, for instance, is an example of your quadratic function, and its graph, as you know, is a parabola. Another example of an explicit function is y equal to the square root of 9 minus x squared. Okay? Top half of a circle centered at the origin. Okay? With radius of 3. Okay? So that one also is an example of an explicit function. And the letter C, y equal to the negative of, this time, the bottom half. Okay? The bottom half of the circle centered at the origin with radius of 3. So these are all examples of explicit functions. Okay? How about implicit functions? Okay, what about implicit? So to differentiate it from explicit function. Implicit if one variable is not defined only in terms of a single variable. Okay, for example, letter A, y minus x squared equal to 7. Letter B, y squared plus x squared equal to 9. Letter C, y to the fourth plus 7y squared x minus y squared x to the fourth minus x to the fifth, 9x to the fifth is equal to 3. Okay, note however that, both example A represent the same parabola. Okay, and letter A could be expressed explicitly. Y minus x squared equal to 7, okay, could be expressed explicitly in terms of x. Y equal to x squared plus 7. Okay, in like manner, looking at letter B, y squared plus x squared, this is letter A. Then we have letter B, y squared plus x squared is equal to 9. You know very well that this is a circle whose center is at the origin and radius of 3. The square root of 9 is 3. Can also be solved for either the top or the bottom of the circle. You can express this as, in fact, you can write this as y equal to positive negative square root of 9 minus x squared. Okay? Y equal to the positive negative square root of 9 minus x squared. Because from here, we'll get y squared equal to 9 minus x squared. And if we extract the square root of both sides, then we'll end up with positive negative because there are two roots. Okay? Positive negative square root of 9 minus x squared. So it could also be solved explicitly. Okay? You can solve it or differentiate it explicitly. Whereas for letter C, y to the fourth power minus or plus 7 y squared x minus y squared x to the fourth power y squared x to the fourth power minus 9x to the fifth power is equal to 3. Okay, is there a way by which we can express the variable y in terms of x? Is there a way by which we can express this into an equation or such that y is expressed in terms of the variable x alone? Look, here you have y to the fourth, although here you have y squared, maybe you could factor out y squared but you will still have y squared remaining here. So we really cannot separate the variables x or the variable x from y. Therefore, this requires the technique implicit differentiation. Okay? So this could be differentiated implicitly. Okay, so for implicit differentiation, we have the following steps. Okay? Yeah, the key to implicit differentiation, this is applying your chain rule. Step number 1, okay, so finding for dy over dx, derivative of y with respect to x, of implicit functions involving the variables x and y. Number 1, treat y as a differentiable function of x. Okay, treat y as a differentiable function of x. And then number 2, differentiate both sides of the equation with respect to x using all the rules that we have previously discussed, and then apply the operator derivative with respect to x to every term and use product, quotient rule, and whichever rule is applicable. Then number 3, solve for dy over dx as if it were a variable. Then follow these steps. Letter A, simplify each side of the equal sign, and then collect all terms having dy dx to one side of the equation, and all the non-dy dy over dx terms to the other side. And then you factor out dy over dx, and then divide to isolate dy over dx. So to come up with dy dx only on the left side. Okay, so for example number 1, implicit, we are reviewing implicit differentiation. Okay, implicit 1 to 2, and then we proceed to the next concept, which is higher order derivatives. So example number 1, although we answered like 2 exercises or problems before, though for emphasis, may we add 2 more problems. Find dy over dx for y squared plus x squared is equal to 9. Okay? So like what we said a while ago, we first take the derivative of every term with respect to x. So we take the derivative with respect to x of y squared plus the derivative with respect to x of x squared equal to the derivative with respect to x of 9. Okay? By recalling all the rules that we have discussed in the previous lessons or sessions rather. So differentiating y squared, this is a power, okay? Apply power rule. So 2y, what are we differentiating? Y with respect to x. So dy over dx plus, okay? Next, again, applying your power rule, derivative of x squared is 2x. What are we differentiating? The variable x with respect to x. However, this is equal to 1. dy or dx over dx is equal to 1. Equals, later you don't have to show this step. You can proceed right away to the third step that we shall be writing in a while. And derivative of 9, which is a constant, is 0. Okay? Derivative of a constant is 0. So simplifying it further, 2y dy over dx plus, what will this be? 1. So 2x equal to 0. Okay? Then, we leave the term having dy dx on the left side, and we move this to the right side of the equation, or applying your addition property of equality. So leave this on the left side. 2y dy over dx is equal to negative 2x. Okay, negative 2x. And then, to isolate, we have to isolate. Okay, we have to isolate dy over dx on the left side. That means we have to divide the whole equation by 2y. Or using your multiplication property of equality. So your dy over dx is equal to negative 2x over 2y. And cancelling out 2, finally, dy over dx is equal to negative x over y. Okay? So dy over dx is equal to negative x over y. Now we proceed to the next example. So for number 2, dy over dx for x squared y plus y cubed x equal to x cubed y cubed. Okay? Okay, x squared y cubed x equal to x cubed y cubed over dx. Again, like what we did in the previous, we take the derivative of the left and the right side of the equation with respect to the variable x. So we take the derivative with respect to the variable x of the left and the right side of the equation. Okay, so derivative with respect to x of x squared y plus the derivative with respect to x of y cubed x equal to the derivative with respect to x of x cubed y cubed. Or you may not show this step anymore. The only one thing you have to remember is that when you differentiate the variable y with respect to x, that's the only time you affix dy over dx. Okay? That's the only time you affix dy over dx to indicate that we are differentiating the variable y with respect to x. But when you differentiate the variable x, you don't have to write dx over dx anymore because you know that it is equal to 1. Okay, now looking at the first term. Look at the first term of the given, x squared y. Okay, which rule are we going to apply for the first term? Okay, the product rule. Okay, product rule because this is a factor, this is another factor. So, apply the UV rule. UV. Remember your UV. Okay, so UV is the derivative of a function that takes the form u times v is equal to u dv plus v du. Okay, u dv plus v du. U is x squared. dv, that's dy over dx. Okay, derivative of y with respect to x plus v du. V, y times du, derivative of x squared is 2x. Okay? This is only for the first term. Now we proceed to the second term. Plus, just the same. Your second term, okay, your second term is also a product. UV. So we have to apply u dv, v du. Okay, u. Okay, here your u is y cubed and your v is x. Okay, so u dv y cubed, derivative of x is 1. I don't have to write dx over dx. Okay, times 1 na lang. Plus, okay, this is u dv plus v du. V x du, derivative of y cubed is 3y squared dy over dx. Okay, dy over dx. Next, so we're moving on to the right side. equals. Okay, equal to. How about the right side of the equation? X cubed, y cubed. What can you say about the right side? It's also a product. Okay? So it's also a product. We have to apply the product rule. Okay? U, V. So applying your product rule, U dV, x cubed. Okay, so x cubed dV, derivative of y cubed is 3y squared. Remember, dy over dx. Because it's the variable y that we are differentiating. Plus u dv. Okay, u dv rather, plus v du. V, y cubed, times du. Okay, v du is 3x squared. Okay, now let's simplify. Okay, let's simplify. Okay, x squared, this will be 2xy. This will be y cubed. Now, to save space, may we now collect or put together or leave all the terms having dy over dx on the left side. Okay, so this will remain x squared dy over dx will remain on the left side. The same is true with multiplying this 3xy squared dy over dx. How about this? Minus 3x cubed y squared dy over dx. The non-dy dx terms will be written on the right side of the equation. Okay, this 3x squared y cubed minus 2xy minus y cubed. Okay? Minus y cubed. From here, what do we do next? Factor out dy over dx. Okay, so let's bring out dy over dx. Factor it out. Factoring it out, here, we have x squared plus 3x y cubed, or y squared rather, minus 3x cubed y squared equals 3x squared y cubed minus 2xy minus y cubed. And then, last step, we isolate dy over dx, or divide the whole equation by this factor. Okay? So, finally, dy over dx will be 3x squared y cubed minus 2xy minus y cubed all over this x squared plus 3x y squared minus 3 x cubed y squared. Okay, so this will be our final answer. So put in mind, when you differentiate the variable y, do not forget to write dy over dx. Okay? Now we move on to the last. Okay, so let's have then the last example for implicit differentiation. This is in relation to finding the equation of a tangent line. Find the slope of the tangent line to the curve x squared minus y squared equal to 0 at the point 1, 1. So how shall we answer this? Okay, looking at the given x squared minus y squared suggests that x squared minus y squared equal to 0. By the form, this suggests that we have to apply implicit differentiation. Okay, so let's differentiate using implicit differentiation. Okay, derivative of x squared is simply 2x minus derivative of y squared. Y cube yung PowerPoint, y cube ito. Okay, thanks for the correction, Paulo. Y cube. So, we differentiate the variable y with respect to the variable x. Apply power rule for y cube. You'll get 3y squared. And what did I say? Affix dy, derivative of y with respect to x, dy dx, equal to derivative of 0 is 0. dy over dx, negative 3y squared rather, dy over dx is equal to negative 2x. Then we get rid of this by multiplying the whole equation by 1 over negative 3y squared. Then we'll end up with dy over dx equal to 2x over 3y squared. Okay, so dy over dx is equal to 2x over 3y squared. But we go back to the problem. What is it asking for? The slope of the tangent line at the point of tangency, which is 1, 1. So, how shall we find the slope? How do we get the slope then? Now, we evaluate. Okay, the word is evaluate dy over dx at the given point, 1, 1. This is your x and this is your y to find the slope. Okay, so the slope of the tangent line, therefore, what are we to do? Evaluate dy over dx at 1, 1. And that gives the slope of the tangent line. So the slope of the tangent line, therefore, will be 2 times 1 over 3 times 1 squared, which is equal to 2 over 3. So the required slope is 2 over 3. Now, we can further look for the equation of the tangent line. Okay, because we have a point on the line and the slope of the line, the point-slope form. Okay, remember the point-slope form? Point-slope form says y minus y sub 1 is equal to m times x minus x sub 1 from your pre-calculus. Okay, y minus y sub 1, 1 equal to the slope, which is 2 over 3 times x minus 1. Okay? Y minus 1 equal to 2 over 3x minus 2 over 3. Okay? And simplifying it further, we'll get y equal to 2 over 3x. That's 1 minus 2/3 is 1/3. Okay, so if the follow-up question would be asking for equation of the tangent line, then this would be the answer. The equation of the tangent line is y equal to 2/3 x plus 1 over 3. Okay, so if there are no questions at this point, then we could move on to the next topic for this morning, which is higher order derivatives. Okay, so when we say higher order derivatives, these are the results after taking successive derivatives of a function. Okay, so if we have f prime of x as the first derivative, then f double prime, f prime prime of x would be the second derivative. That means, get the derivative of the first derivative. The third derivative means, get the derivative of the second derivative, and so on and so forth. Okay? Higher order derivatives. Okay, let's look into some examples of higher order derivatives. Find the third order derivative. So, f prime of x is your first derivative. Okay, derivative. Or y prime. Okay, y prime or f prime of x or dy over dx. So, it could be y prime or it could be dy over dx. Could be y prime. It could be f prime of x. These are the notations. Okay? For second derivative, the second derivative, the superscript 2 after dy with respect to x. So, y double prime or f double prime of x. This is your second derivative. Okay? The third derivative or d cube y. The third derivative of y with respect to x is equal to y triple prime or f triple prime of x. The third derivative. And so on. Okay? So you can continue taking the derivative until the nth derivative of y with respect to n is equal to y prime n prime equal to f n prime of x. Okay, the nth derivative. Okay, the superscript here or the exponent would tell you the order. Okay, the order of the derivative. Is it the first order, second order, third order, and so on. Now, going back to problem number 1. What is it asking for? Find the third order derivative of y equal to example number 1. Find y triple prime na lang tayo or the third derivative of y with respect to x of y equal to 4x cubed minus 12x squared plus 6x plus 10. First derivative, dy over dx. Apply power rule and sum difference rule. Constant multiple rule pala. So this is 12x squared minus 24x plus 6. Derivative of 4x squared is, or 4x cubed is 12x squared. Derivative of 12x squared, 24x. Derivative of 6x is 6. And derivative of 10 is 0. Okay? Next. The second derivative of y with respect to x is equal to, we differentiate the first derivative to get the second derivative. What will this be? 24x minus 24. Okay? And derivative of 6 is 0. And finally, what is asked for in the problem? The third derivative. So, d cube y over dx cube equal to derivative of the previous is 24 and derivative of 24 is 0. So, the final answer is 24. Now, if I ask you, what is the fourth derivative? What's the fourth order derivative of the given? Okay, 0. Oh, correct, 0. Next problem. Okay, given f of x equals the square root of 4 minus x squared. Okay, what are we going to find? We are to look for the second order derivative. determine f double prime of x. Okay? F double prime of x. Now, looking at the form of the function given, what rule is applicable to the given? What rule shall we apply to take the first derivative? Looking at it, f of x is equal to the square root of 4 minus x squared, the GPR, okay? Or the generalized power rule. Okay, differentiate by using GPR, generalized power rule. So we transform or rewrite the given into its exponential form. So the given f of x is equal to square root of 4 minus x squared could be written in exponential form as 4 minus x squared raised to 1/2. Okay? So now we are ready to apply the GPR. F prime of x equals, from your generalized power rule, u to the n 1/2 times u 4 minus x squared raised to 1/2 minus 1 times derivative of the radicand. Okay? Derivative of 4, 0. Derivative of negative x squared is negative 2x. Okay, let's simplify before we proceed to getting the second derivative. Take note that 2 and 2 would cancel out, right? So, what do we have? What is left? X, negative. Okay? Negative x times 4 minus x squared raised to negative 1/2. Okay? Negative x times the quantity 4 minus x squared raised to negative 1/2. You can see that here. F prime of x is negative x times 4 minus x squared raised to negative 1/2. We proceed to the next because this asks for the second derivative. So we have to continue. Now, okay, take note that the first derivative, okay, what can you say about the first derivative? Look at the form of your first derivative. We have negative x multiplied to the quantity 4 minus x squared raised to negative 1/2. It's a product. Okay? So, this takes the form UV. Therefore, to get f double prime of x, we have to apply the product rule. Once again, f double prime of x equals u dv v du. U, negative x. Okay? dv. dv, differentiate the second. The second factor is a power. Okay? So, apply power rule. Exponent, negative 1/2 times, okay, 4 minus x squared raised to exponent minus 1, that will give negative 3/2. Can you follow? Negative 3/2 times, take note, this is our u and it's still differentiable. So you still have to differentiate 4 minus x squared, which is derivative of 4, 0. Derivative of negative x squared is negative 2x. This is just your u dv. u dv. How about v du? Okay, let's continue. Plus v du. V ito, buo. Okay, 4 minus x squared raised to negative 1/2 times du, derivative of negative x is negative 1. Again, v du. u dv plus v du. Okay? Now, let's continue simplifying the given or the our answer, f double prime of x. equals. Which terms can we multiply? Or which factors rather, sorry. Which factors can we multiply? Look, this, ito, and then this. But what happens with negative 2 and negative 1/2? Will cancel out, yes? Okay, so this will cancel out with 2. Okay, negative 1 times negative x is positive x times negative x is negative x squared. Okay, negative x squared times 4 minus x squared raised to negative 3/2 plus or minus. Okay, minus 4 minus x squared raised to negative 1/2. Okay, let's just simplify this. So your f double prime of x will be equal to, okay, to make the exponent positive, we will write this in the denominator as well as the second term. Okay, we will do the same to the second term. So your f prime of x will be negative x squared all over, yan, all over 4 minus x squared raised to 3/2 minus 1 over 4 minus x squared raised to 1/2. Is there another way of writing this? The first fraction has the denominator 4 minus x squared raised to 3/2, and this has the denominator 4 minus x squared raised to 1/2. So get the LCD. The least common denominator is this. Okay, so we have to multiply the second fraction by 4 minus x squared. Okay? Let me copy the first fraction. Negative x squared all over 4 minus x squared raised to 3/2 minus 1 over the quantity 4 minus x squared raised to 1/2. Okay, what should I add? Okay, what should I add to 1/2 to get 3/2? Diba 1? So we multiply the numerator and denominator of the second fraction by 4 minus x squared. 4 minus x squared. Bakit? Diba this is raised to 1? 1 plus 1/2 is 3/2. Remember, you can only add fractions if they have the same denominator. Okay, so expressing them into similar fractions. So what do we get now? F double prime of x equal to negative x squared over 4 minus x squared raised to 3/2. Okay, minus, yan, 4 minus x squared. 4 minus x squared over 4 minus x squared raised to laws of exponents. When we multiply powers of the same base, we add the exponent. So 1 plus 1/2 is 3/2. Are they similar now? Yes, they now have the same denominators. That means we can combine or write them into one fraction only. F double prime of x equal to negative x squared minus 4 plus x squared. Okay? Tama? Minus 4 minus 4, negative, negative, positive, all over 4 minus x squared raised to 3/2. What will this be? Negative 4 over 4 minus x squared raised to 3/2. The final answer is negative f double prime of x is equal to negative 4 all over 4 minus x squared raised to 3 halves, or in radical form, negative 4 over the square root of the quantity 4 minus x squared raised to the third power. Did you understand this? So, ito yung buong solution niya. Next, how about an implicit function? What if we have an implicit function? Problem number 3. Consider the function x squared plus y squared equal to 25. Find the second derivative of y with respect to x. Again, the form of the given suggests that we have to differentiate implicitly. Okay, when you differentiate the variable y, that's the only time you have to write dy over dx. Okay, so differentiate both sides of the equation with respect to x. Derivative of the first is 2x. We have to write dx over dx, no need. Plus, derivative of the second, look, it's y that we are differentiating with respect to the variable x, so not only 2y, but you have to affix dy over dx. Okay? Equal to derivative of 25, is 0. Okay? So, 2y dy over dx is equal to negative 2x. Divide both sides by 2y. What will dy over dx be? dy over dx will be negative 2x over 2y is negative xy. Okay, so this is our first derivative. dy over dx equal to negative x over y. That's the first. Let me enclose it in a box. But we're not done yet because this problem asks for second derivative. Okay? So, just the same, we take derivative of both sides of the equation. So, if I get the derivative of y with respect to x, then that is already d squared y over dx squared. Because this is already the first derivative. If I get the second derivative, then that's second derivative of y with respect to x equal to. Now, look at the right side. What form does it take? What form does it take? X over y. Negative x over y. Okay? Obviously, the right side of the equation takes the form u over v. Diba? This is your u and this is your v. Therefore, we have to apply the quotient rule. Correct. Quotient rule. So, by quotient rule, v du minus u dv over v squared. Okay? v y. du, derivative of negative x is negative 1. Minus u dv, u. Okay, u, negative x. dv, it's y that we are differentiating. What did I say? You have to indicate dy over dx. Derivative of y is 1 dy dx or dy over dx. Can you follow? All over v squared, y squared. Simplifying it further, then the second derivative of y with respect to x is now equal to negative y plus x dy over dx all over y squared. Okay? From here, copy negative y plus x times, what is dy over dx? Let's go back. Yan. dy over dx is negative x over y. Okay? Negative x over y. So, I will replace dy over dx with negative x over y. All over y squared. Okay, let's simplify further. The second derivative of y with respect to x is now equal to negative y minus x squared over y all over y squared. Take note that we ended up with a compound fraction, ano? It's a compound fraction, so let's simplify further. D squared y over dx squared equal to, what will this be? Negative. This is negative y squared minus x squared all over y. Correct? Negative y squared minus x squared all over y times, since we don't have space here, remember that division could be expressed as multiplication provided that we get the reciprocal of the denominator. Yes? So, any questions on how we got this? Negative y squared minus x squared all over y times, get the reciprocal of the denominator, diba? Times, kasi wala tayong space, kaya gawa tayo ng paraan, may sulat lang ang sagot. 1 over y squared. Correct? So, from here, what will our final answer be? Our final answer will be what? Negative y squared minus x squared all over y cubed. Okay? Okay, let's answer number 5. Bakit x squared? Dagdagan ko kaya ng cube. Okay, 4x squared minus 9y squared minus x plus y equal to 1. Find the second derivative of y with respect to x. Again, looking at the form, magsama-sama si x and y sa isang side of the equation, implicit. Okay? Applying implicit differentiation, differentiate 4x squared. What is it equal to? 8x minus differentiate 9y squared. 18y dy over dx minus derivative of x, 1, plus derivative of y is dy over dx. Get it? Equal to derivative of 1, 0. So, we differentiated every term with respect to x. Ulitin ko, if you differentiate the variable y, please affix dy over dx. Huwag kakalimutan. Now, okay, all terms having dy over dx, collect them on one side. Okay, so negative 18y dy over dx plus dy over dx equal to negative 8x. Okay? Tama? Minus 1 or plus 1. Correct? Negative 8x plus 1. Then, factor out dy over dx. Negative 18y plus 1 equal to negative 8x plus 1. Then, finally, isolating dy over dx. Dy over dx will now be negative 8x plus 1 all over negative 18y plus 1. Okay, so we're done with the first derivative. Okay, tapos na tayo kay first derivative. Now, we proceed to getting the second derivative. Okay, so we get derivative of the left and the right side of the equation. The second derivative will now be d squared y over d x squared equals. Again, look at your right side of the equation. Anong forma niya? It's a quotient. Okay? Bilisan na natin para hindi maubos na ang data ng iba. Pawala-wala na sila. Okay? UV. U over V. So, V du minus U dV over V squared. V, negative 18y plus 1 du. Derivative of negative 8x is negative 8. Derivative of 1, 0. Minus U dV. U minus negative 8x plus 1 du. Derivative nito is negative 18 dy over dx. Okay? All over the square of the denominator. Negative 18y plus 1 squared. Okay? Let's continue simplifying it. By multiplying or by multiplication, you multiply negative 18y plus 1 by 8. That's 4 carries 6. 144. Tama? 8 times 8, 64. 4 carries 6. 8 times, okay, 144. Positive. Tama? So, from here, d squared y over dx squared equal to, multiply the 2, you'll get 144y minus 8 minus, just the same, 144x minus 18 dy over dx all over the square of the denominator, negative 18y plus 1 squared. From here, what do we do next? Replace dy over dx with this. Okay? Can you do that on your own? Do it on your own. Replace. Ito. dy over dx. Ito lang naman. By ito. And then multiply. And then simplify. Squared y over 144y minus 8 minus the quantity 144x minus 18 times ito, dy over dx, ito negative 8x plus 1 over negative 18y plus 1 all over negative 18y plus 1. And simplify further. So, this squared y over x squared equal to, this is, the two are being multiplied. Ito, this is a separate term. Simplify further. Okay? What will this be? This will be 144y minus 8 minus, this will be a fraction. Multiply it. Okay, multiply the 2. What will you end up with? 144 times 8. Multiply the numerator and over the denominator, and just the same. Pareho lang pala. Yung answer niya, 1152 x squared minus, plus 288x 288x minus 18 all over negative 18y plus 1 all over negative 18y plus 1. Again, combine these two. Ito naman, multiply nyo so that it will be expressed into a single fraction. So, 144 times 18, correct? 2592y squared plus 288y minus 8. Okay? Minus the whole of this, 1152x squared plus 288x minus 18 all over negative 18 y plus 1 times, para makasave tayo ng space, times 1 over negative 18y plus 1 to the second power. Ito, multiplying 144y minus 8 by negative 18y plus 1, you'll get this, 2592y squared plus 288y minus 8. Okay, minus 8 minus the whole of this. 1152x squared plus 288x minus 18. Then all over negative 18y plus 1. Okay, all over the denominator. Negative 18y plus 1 to the second power, or get its reciprocal and proceed to multiplication. Okay, now let's proceed. We continue further. Then d squared y over dx squared will now be other terms that can be combined. Ito lang. Okay, the rest we simply copy. 2592y squared minus 1152x squared plus 288y minus 288x to plus 10. Correct? Plus 10? Is it plus 10? Look at this. Negative of negative 18. Correct? Plus 18 minus 8 is 10. Correct? Plus 10 all over. Okay, multiply this with this. What will happen? What happens with the numerator, or sorry, the exponent rather? The power will now be negative 18 y plus 1 to the third power. Okay, this is it. Okay, this is
Ma'am,
the
negative 2592.
Negative? Yes, correct. Negative from here. Okay, negative 2. Ito. Yan. Negative 259, negative 259. Tama na? Okay, negative. This one will be positive. Okay, 144 plus 144. Tama? Positive 288. Did you get the same answer? Final answer? So the final answer is this, negative 2592y squared. Let's enclose it in a box. Okay, as much as possible, express your final answer into a single fraction. Okay, goodbye everyone. Happy weekend.